Okay, here's another example with, well, Mikhail, that's probably good that you lost the triple mind sweet game you're playing because you got an example to copy down now. That's right. That's right. Minesweeper. I'm not sure what that game is, but it sounds like there might be some explosions. All right. So let me let you copy this example down, um, and then we'll go over the solution. Be right with you. Okay, so let me see. Uh, One moment here. Hold on, everybody. I got to find that chat message. That is correct, Mikhail. We're going to work this problem just like we did the previous problem. It's just we have an extra dimension. We're going to use homogeneous coordinates, but this time, because well, what do we have? We have a figure in R cubed, three-dimensional space. We want to find a 4x4 matrix that transforms a figure by rotating it counterclockwise about the y-axis through an angle of 30 degrees. Okay, and for this problem, we're going to allow the homogeneous coordinates. Now, we're not doing any shifting of the figure, translating of the figure, but homogeneous coordinate, nevertheless, we want to use them because we might want to do a translation at some point. This would be the homogeneous coordinate, x, y, z, with a 1 at the bottom. Homogeneous coordinates. So, okay. What we have to do, if we think about the matrix that we need, it needs to be a 4x4 matrix. And we know that the perimeter of the matrix is going to have those entries. Okay, again, there's no translation going on. The bottom row is 0, 0, 0, 1. And the last row is 0, 0, 0, 1 because there's no translation going on, okay, of the coordinates. So this leaves this 3 by 3, okay, and you have 9 entries. And those entries, okay, well, there are, think of them like 3 vectors. And by theorem 10 from section 1.9, the first vector would be the transformation of the E1 vector. Okay, that's 0, 0, 1, 0, 0, transform of 1, 0, 0. Second vector would be the transformation of the vector 0, 1, 0 under this transformation, this rotation. And then the third vector here would be the transformation of 0, 0, 1. So the best way to find those 3 vectors is to actually construct a picture where we are rotating the vectors E1, E2, and E3, those unit vectors, about the y-axis through an angle of 30 degrees. And so for the solution here, I mean, here's how basically you have to do it. I drew a 3-dimensional picture where I show a rotation of 30 degrees counterclockwise about the y-axis. Let me give you a moment to copy the picture down. Okay, take a moment. Okay. That's right. That's right, Mikhail. And well, so hold on. So what you're doing is you're looking at the positive y-axis. I want to say this the right way. I mean, let's focus on E1, that unit vector. Okay. Here's E1 with coordinates 1, 0, 0. And you're rotating it counterclockwise 30 degrees. So the way you look at it, it's like you're standing on the positive y-axis, and that's how you're doing the rotation. You're standing on the positive y-axis, and you're looking at the vector E1 from, like, you're like standing here. Okay, there you're standing, and you're looking at the vector E1, and you move it counterclockwise 30 degrees. So it's like the clock is in the XZ plane, so to speak. So this is your transformed vector then, right here. Now, what is that transformed vector? What are its coordinates? Well, if you think of the 30, 60, 90 right triangle, okay, that's going to come from right here. So what I'm doing now is I'm looking at the XC plane, and I want to be a little careful. It's like I'm standing, well, that's the XC plane, 30 degree, and you're moving the 1, 0, 0 vector down 30 degrees. Here's the transformed vector. And, you know, these are the sides. So the transformation of E1, okay, based on my little picture here, has to be root 3 over 2, 0, and negative a half. Let's make sure you're comfortable with that. I want to make sure you're comfortable with that. Notice the y coordinate is 0. That doesn't get, you're doing a rotation about the y-axis. So that's not going to change the y coordinate at all, but it will change the x coordinate and the z coordinate, of course. So this point here has coordinates root 3 over 2, 0, negative a half. Those are its xy coordinates. This point right here. Now, if we go up to the picture again, the E2 point, hold on here, which is right, maybe I'll put it in blue just to change the color. Here's the E2 point. Let's just put that. That stays. Okay, that point is on the y-axis, so that didn't get moved at all. So that's still 0, 1, 0. And so this gets us our second column vector that we need. And then finally, the vector E3, which is up here, the vector E3 gets moved to here. And again, if you just look at the geometry of the situation and the fact that you have a 30, 60, 90 degree right triangle, the coordinates of the transformation have to be a half, 0, and root 3 over 2. Try to make this look nice. Yeah. I mean, there's really no other way to do this. No other way to do this. Are there any questions? Any questions at all? I'm going to get to the matrix now, our 4x4 matrix on the next page. We have just a couple minutes left in class, so I will get there. But are there any questions on this? So in your homework, you'll have situations where you're rotating, you know, about the x-axis, maybe 45 degrees, clockwise, counterclockwise, anything's possible, you know, and this is how you would handle it. This is how you would do it, and you're making use of theorem 10. May I go to the next page? Are we good? Okay. Kale's good, Cameron's good. Let's make sure a few other people are good. And then we'll go to the next page. Jacob's good. Okay, wonderful. Okay, Jonathan and Marcella are good. All right, great. Okay, well, then here is your matrix, 4x4 matrix. And this is the vector, which is a transformation of the E1 vector. Here's a transformation of the E2 vector. And here's a transformation of the E3 vector. And that forms the top left-hand corner of the 4x4 matrix. The MyMathLab homework, as well as the exam, is going to want simplified, it's going to want answers in simplified radical form. So make sure you do that. It has to be that. If it's a decimal, we'll count it wrong. Okay, and yeah, Mikhail, 1/√2. MyMathLab might take that, but it might want √2/2 instead. It might want that instead. You have to be careful, and that's why, with the homework, you kind of see that, and then you're a little better prepared for the exam. All right, I'm going to stop the recording if we're good. Okay, excellent.